Hello. Now we're going to look at a few special cases of triangles that would tend to have particular names and particular facts that we need to know about them. We're going to start off with an equilateral triangle. So lateral means a side and equi means equal, so they have equal sides. So equilateral triangles have all the same side lengths. And a consequence of that is that they all have the same angle. And if we think about the fact that they have all the same angle, we have three angles that are the same. We know they add up to 180. So each angle must be 60 degrees because 60 plus 60 plus 60 would equal 180. So we automatically know if we have an equilateral triangle that the angles inside must be 60 degrees. No matter how big or small the triangle is, if it's equilateral, if all sides are the same, the angles inside must be 60 degrees. And we need to know that as a fact in the back of our minds, as a tool in the back of our minds going forward. Another type of triangle we can come across is an isosceles triangle. An isosceles triangle means that two of our sides are equal. So we can see here with our equilateral triangle, we had our marks on our sides and it was all the same type of mark. That means that they are all the same length. And with our isosceles triangle, well, we have two sides the same length. So we could have the same symbol here. So here we have two dashes, here we have one. It doesn't actually matter. So long as the symbol is the same on each side, that means that they are equal. So the fact that we have two dashes here and two dashes here means that those sides are equal. We have one dash on each of these sides, which means that they are equal. So if we have two equal sides, there's a consequence of that for the angles, because it means that this angle here across from our equal sides must also be equal. So both of these angles must be the angle A. We don't perhaps know what that angle is, but we do know that they are the same. So the angles opposite the equal sides are equal. They are the same as well. And that's an important fact for our isosceles triangles. The next type of triangle we want to talk about is a right angle triangle. We will do a huge amount of work with right angle triangles, but for right now, the only things we need to keep in mind are the symbols involved and the names of one of the sides, because they have a special name. So for a right angle triangle, it's a right angle if one of the vertices has an angle of 90 degrees. So we know our vertex, our vertices of our triangle are our corners of our triangle. And if we have an angle down here of 90 degrees, that means it's a right angle. So 90 degrees means a right angle. And across from that 90 degree angle, we have the hypotenuse. It's an old Greek word, and it means the longest side, the side across from or opposite from the 90 degree, from the right angle. And we will do a lot more work with these in the long run, but for now, that's all we need to know. And finally, scalene is the name for where we have a triangle where all of the sides and all of the angles are different. The final thing to mention, and something that's true for all types of triangles, is that the biggest angle would be across from the biggest side. So we can see the largest angle in our triangle here is across from the largest side. The largest angle here is across from the largest side. And in our isosceles case, the longer sides are actually both equal in that particular isosceles triangle. So if we know that we have the largest angle, we know that opposite that is going to be the largest side, and vice versa. And if we had the smallest angle, it would be across from or opposite from the smallest side. And that can be useful for lots of problem solving as well, if we think about that as a logical necessity. Now, can we use what we've discussed here to figure out any of our problems? So we can see here we have what type of triangle. That's the first job we've got. What type of triangle have we got? We've got an isosceles triangle because I have a mark here and a mark here. I don't have one here. So that tells me that two of my sides are equal. So I have an isosceles triangle. So what do I know then? Well, the angles opposite the equal sides are equal. So if I'm looking for x, I know that x must just be equal to the other angle opposite the equal sides is going to be 30 degrees because they are isosceles, because I'm in an isosceles triangle. And whenever we can, we're always going to write in why what we're saying is true. So I don't just write down x is equal to 30 degrees. I write down x is equal to 30 degrees because isosceles triangle. We are in an isosceles triangle. Now that I know that, I can write that in. Note to myself, I now know that's 30 degrees. How am I going to find y? Well, I now know with a triangle that the angles in a triangle must all add up to 180. So x plus y plus 30 must all add up to 180, and I know that x is 30 degrees. So I have 30 plus y plus 30 is equal to 180. Add up my like terms. So I have y plus 60 is equal to 180. And get my y by itself. And y must be equal to 120 degrees. Now here, I'm asked to find the angle Z. So I've got, what type of triangle have I got? I've got another isosceles because I have this side is equal to this side. So I have two sides equal. So what does that allow me to work out for the angle Z? Well, I know that if I add up all three angles in a right angle triangle, I must get 180 degrees. So that's one fact that I know. And I know that the angles opposite the equal sides are equal. So that allows me to say that this angle here must also be the angle Z. So those two angles must be equal to each other because we've got an isosceles triangle. So that tells me that Z plus 80 must add up to 180 degrees. So 2Z plus 80, I add up my like terms. This is just solving an equation. So I added up my like terms. I had my two Z's. So I have 2 times my angle Z plus 80 must add up to 180 degrees. Rearrange to get the Z stuff by itself on the left-hand side. Divide by the coefficient of my letter to get Z by itself, and Z must be equal to 50 degrees. Finally, if we get a problem like this is a bigger problem. We now need to look at all the information that we are given. So I can see here, I'm told that ABC is 90 degrees. So I know this complete angle here, A to B to C, is a right angle. So I'm going to draw that in. That whole angle there is 90 degrees. And I'm asked for the angle ECD, E to C to D. So I'm looking for this angle here. So I'm going to call that the angle B. So little b for my angle. I'm looking for that angle there. I'm going to draw that in on my picture. I'm not going to try and keep it in my head. I'm going to actually draw it on my diagram, just like I drew in my right angle on my diagram. Well, what else can I fill in my diagram? I know I want to find this, but in my geometry problems, I'm often going to try and fill in all the information that I've got and see if that helps me. Well, I can see here, this triangle here is equilateral. It has all three sides the same. So what does that tell me? Well, that tells me that this angle here is 60, this angle here is 60, this angle here is 60. And I fill in that information so I can keep track of what I know. Now, at this point, I just try to keep filling in information. So I can see I want this angle here. I have this angle of over here, and I'd like to know what else I can do. I think I now have enough information. There is something to point out. I could find out the angles in this triangle as well. I know that this complete angle going around here would be 60 plus something is 180. So I know that that would have to add up to 120. I know that this angle here would be 60 plus something is 90. So that angle there must be 30. So I'd be able to find out my missing angle all the way down here. That would be 30 plus 120 is 150, plus something would give me 180, because I have this smaller triangle in here must also add up to 180. The angles must add up to 180. So I can find this angle in here. So that would be 130 plus 30 plus 120 would be 150. So this angle of in here must also be 30 to add up to 180. So this diagram is not drawn particularly neatly. Now that I know that this angle is 30 degrees, I can say that the angle I'm looking for, my ECD or little b, is vertically opposite from 30, therefore it must be equal to 30. So simply by going through the diagram, I'm able to work out that b must be equal to 30 degrees. Now that's not the only way that we could solve that problem. We would also be able to work that out in the following way. So that's one way that you can tell yourself the story of the problem, by filling in the diagram, and that is a perfectly good way to do it. There's another way to approach the problem that we're going to talk about briefly. We know that this angle here is 90 degrees, and we know that this angle here is 60 degrees. And then if we think about what this angle here would be, well, that would be the sum of the two interior opposite angles. So this big angle out here would have to be 60 plus 90. So let's give that angle a name. What will we call it? M, I think. So little m. So m would have to be equal to 60 plus 90 is equal to 150. And then we know that m plus b would have to add up to 180, because it is just on a straight line. So that means 150 plus b would have to equal 180. And rearranging that formula, b would have to be equal to 30 degrees, which we already knew, using a different argument. So again, it's critical as we go through geometry that we look at these storytelling methods from as many different ways as possible, because as these questions get more complex, it will be really important to have all of these tools available to us in our minds. And the way that we get good at that is by looking at the diagrams we've got and telling ourselves the story in several different ways. And we explicitly say why we can do what we're doing as often as possible, so that those rules, those ideas, those tools are well laid down in our minds, in our long-term memories, so that we have them when we need them. And that is what we need for now.